echoing. I know it's echoing, so let me just turn the echo because it's really echo too much. So let me just remove all the echoes before I do anything else. So this should not will be here. One second, guys. I'm sorry. It's recording, but the echoes are not really they're coming out here. I'll remove this one. I don't have anything dangerous here. Just remove this one again. This lady's kind of cute. This is my type of lady. This is why I put her there. Sarumi Takama. She's fake, but this is a persona. She's a volleyball player in Japan. And, and then we'll remove this one more thing. Remove this here. Okay, okay. Now, okay. Today, video. Okay, today is something called bioinformatics. Now, bioinformatics is more about philological laser principle. It's basically how we observe the world and gain information from it. It's more sustainable information from it. It's like based on phenomenological lensing principle or the PLP framework. The bioinformatics foundation or working hypothesis is just that we have we able to we observe our five senses like information is around us naturally, but we only observe a sight of set specific because we don't do analysis on the physiological level, on the biology, on us to really understand how that information ties into the greater aspects of things. So biological informatics is more about sustainable information. But Nnamdi is based on a Hamiltonian and Eulerian. So I have to give an example now. So still we have something called a sparse graph. A sparse graph is defined by a Hamiltonian cycle, H, an Eulerian graph. Eulerian graph has edges because now you gotta have an E, E to Q, EB, birth first, Q. So basically, Nnamdi, H, no, so basically, so the E stands for Illyrian, and Illyrian circles people with the breadth first search. That means they go layer by layer instead of depth by first. And homotopy control search by so Illyrian equals B. If you flip the B Nnamdi, you get a Q, which is the first in, first out structures equal to the breadth first search, and the Hamiltonian Hamiltonian and Hamiltonian is a depth first search, which means like you go down the layers recursively descent, which was where the recursive descent come from the powers of methodology. Breadth first search and depth first search are isomorphic in some notations, but they're not all the same. So the problem is, when you have two functions that do the same thing, one uses Hamiltonian depth first search, and the other uses Illyrian. They do the same thing, but it's not being faster. It's about are they doing the same thing? You don't know they're doing the same thing, but are they working as intended? If you have two different instances, two systems doing the same thing, but they're not working together like that, they're in desynchronization. So the system would not even know how to resolve the desynchronization. It won't be aware of the other function because the other function doesn't know the state of that function because it's not isomorphic. There's no way to show even though you expose it to the PLP layer for 95.4, they're in dig sync. So one is doing the job one way and the other is doing the job the other way, but they do the same job. So same problem. It's just Hamiltonian breadth first search using last in first out. So bioinformatics is a study of information based on sustainability for phenomenological lesson principle. The bioinformatics is more of a it's like a geocode, Nnamdi. Geocode, geomorphic core library. Based on latitude and longitude and latitude, and basically you got the world is round, it's a sphere. You got the latitude, you got the longitude, and you got the Tropic of Cancer. You got the equator across the Tropic of Cancer, and wait, the Tropic of Cancer at the bottom, right? At the top, Tropic of Cancer, like the more exotic zone of Cancer, the Tropic of Cracula. For this bioinformatics will be very good. For there's something called sparse geometry. Sparse geometry problem will be if I am stranded in a position and I just got lost somewhere and I find my phone, I get it working, how can the system I'm using navigate me through the dense forest of the Tropic of Capricorn? How would that work? A Tropic of Cancer, a Tropic of Cancer, of Capricorn. Just like here, it's the one at the bottom. The thing is like meant to understand the state of the machine as well as the person's frame of reference. To navigate that system based on what it sees already and what the human has been through. So the thing about this system is the bioinformatics. Is not we don't see that we know everything with bioinformatics. We're saying that we need to know enough to do something. Now the term sparse is like sparse. SP. There's a word for it. It's like a locality. Because sparse anything sparse refers to the subset. You can call it a substrate, but substrate sounds more rigid. But sparse data or a sparse matrix can be used to solve this geometric problem because it knows the person backtrack how to backtrack the person and what the person already knows about that state because that was his state previous last state. The sparse geometry is really not being about fragmented, but it's about collecting the dots, really. So if I start from this graph node, this cluster setting, a grid, then I go from there to another grid, the sparse matrix updates, and again you sparse local info, and I can see this the local minimum, the local maximum, and that's based on the PLP framework. The problem trying to fix the sparse informatics system is one of them. It's one of them. This very problem is for geocode, geometric function code, and blue share. Blue share is a polyglot Bluetooth system that it shares data and enhances sparsity, and that's what the information. People share information about the location about unknown zones should be able to find it. What issue? Because the data is logged and sent, and it will never be interpreted because it knows where it's going to. It knows where it's really been. It doesn't need to send it data twice. And this brings more to a very important. Doesn't need to send the data twice. This because you gotta remember that, guys. I won't say it again. Doesn't need to send the data twice because it really knows where the data is. Because it really knows to cluster or nodes to go to based on a decentralized model where we have like nodes in some kind of a peer-to-peer, hybrid or bus ring topology model based on the fault-tolerant architecture and fail-safe mode to ensure the system remains clean and the sparse growth can update network nodes on the fly, add new nodes if necessary, like blue share nodes. So this brings my next question. Bioinformatics as a relay system. So bioinformatics. So we have the internet, but we can unwind it. We can archive it. Oh no, if we archive the internet and then send it out in space, an alien would have something to kill it because he doesn't know what the internet is, like the whole internet. But I'm not really talking the internet to be sent, and what does that mean? Do we send the internet data? Do we send the internet data or do we send the whole internet, our model of the internet in a compressed format they can de-bootstrap or bootstrap themselves? What would that actually look like? One. So instead of doing that, I'm thinking more of if we are the aliens, we're trying to understand how to talk to other aliens. And they send us a message. We don't know the message, but we know there's patterns to it, but we don't think about the patterns. So, because the patterns takes a long time. So instead of that, we just have the message or the data, whatever those send us, in a relay, like a personal member, and we can probe its inputs to see how it behaves on our end. Because these are aliens we don't know of, and we don't know whether it's a hostile or not. But the thing about the relay system for bioinformatics, the bioinformatics relay zone, it's like the consume based on an observer consumer model and the consumer to observer model. If the observer first, then the observer knows is listening. If the consumer first, the consumer is using first before listening, and vice versa. The thing about this is the bioinformatics allows reproducibility of a relay because it's always sustainable and doesn't need to go down. It reminds me of this kind of problem because this problem is like if I want an internet connection and my internet connection is down in the rainforest, How do I can't send anything, but it says like 6G left, 6 like small data like 1 KB, 3 KB left. Then it's my phone dies, and then I give my phone, it's 1 KB left for data. Now, how information solve this problem is like it's still got the data, yes, but my battery is low, so I can just use my one data, but biological information is in the data to connect the internet. So Blue Shell will just collect update the notes, and then I'll connect to the internet. But I can add more notes and everything because the data is a bit stronger if it's faster for me to get out there, and the information is sustainable. But the information stream of the internet, can I replay the whole entire internet? Based in that state. Because you say if I have 1G, if I have 1G, because if I leave the internet on and I want have 1G, can I go back to that state? It's like because the thing is like by information, the study of information, what we're using, what we're doing. It's like can I replay the internet? Can I just take my computer, connect to the internet, and replay of a message that was there like 10 years ago on everyone's computer? Exactly the same one, but using some algorithm, predefined roles, an algorithm that sets a state or a date to sparse locality, pick up this big current token or anything, and then play it back on when it's done. This is what I'm talking about, biological informatics, something that preserves itself in a perceptual memory, and based on constructive and deconstructive proof. Like for me, I have to construct an idea, show that I can do something, something works in practice, and then deconstruct it on the other end, if sure it doesn't work. This is a pilot one for AI hallucination and other things, to see whether AI does that. And yes, that's biological information for you, for sustainable infrastructure. Everything obelisks is like biological, biome. Can a system of sparse matrix be used to resolve a vector, based on update patterns of the matrix? And what would I look at that with functional frameworks? Using because I'm not. Let me try to model it as actually. So the function here, 1 second, 1100. So this would be a matrix. This is my position. Let me just make one. Let me just make it uniform. 1, 1, 2, 3, 4. But I'm trying to multiply this. The function framework here is a this function. I can define that as the dot product, the u product. Yeah, the dot, the cross of this matrix is. But I just got a matrix here. This is a matrix here, and let me write it down bigger so I can try to solve it myself. I don't think I can solve it now, but I think I can solve it later. But what I'm trying to do now is define a matrix that uses constructive and deconstructive proof to show an encoding state of a vector, which something that represents a duplex stream, can be replayed on the other end and 100% reproducible. That would mean that the internet is broken anyway, but because the system allows for information to be stored bi-directionally, and anything that gets destroyed doesn't really get destroyed; it gets emitted into space, like in radio waves. So if I can replay the radio waves or the right amount of information, using Roy GB, which of you give out of it? No. Rent money is only visible under X-ray glasses. Radio waves, microwave, infrared, visible light, gamma rays, X-rays, uh, uh, gamma rays. I'm trying to install like if I can just replay the whole internet, what would it look like? With just just like downloading not even downloading, but just streaming it as it happens in real time, and then unwinding the stream to redoing whatever the relay, doing whatever the relay wants to do in real time. It makes you think of information as fragile because information is fragile when no one knows its intent. But if intent doesn't match the outline, then that people is mimicking the system, and the system can detect that mimicry 100%. But that's what biological information informatics is. It's very non-speculative, and it's meant to resolve things like Hamiltonian gases to Eulerian local min maximum to because Eulerian glyphs are not as similar to the Hamiltonian graph, and how systems are actually interact in the real world. Thank you guys. So have a lovely day. I'm going to save this video.